Good evening to all. In this video, let us see about the fluid mechanics and its properties of various fluids. So, fluid mechanics is the branch of science which deals with the behavior of fluids at various forms, like that is fluids at rest, which is known as static fluid, fluid in motion, where but the pressure forces are not considered. It is fluid kinematics, and fluids in motion, where the pressure forces are taken into consideration for all its application and also the calculations. It is called as fluid dynamics. So the study of all these three uh, positions of fluids is termed as fluid mechanics. In fluid mechanics, we generally deal with hydraulic fluids. Whenever fluids are considered, we have both hydraulic and pneumatic fluids. Hydraulic fluid is fluids which are in the form of liquids, and pneumatic fluids are fluids which are in the form of gaseous form. So the standard hydraulic fluid is water always, and the standard pneumatic fluid is atmospheric air. So why we call it as a standard hydraulic fluid and standard pneumatic fluid is for various derivations and various calculations, we have to compare it with the standard fluid, so that only we need to know what is a standard fluid and what is a why is it so. So that is one. Then we can enter into the properties of fluid. The first property and the important property of any fluid is density, because the density of the fluid is a primary factor which determines the place of application of the fluid. So density is the important property. It is defined as the ratio of mass to the volume of the fluid. So mass per unit volume is known as density, which is represented as rho. So the next property is the specific weight or weight density. It is the ratio between the weight of the fluid to the volume of the fluid. So it is represented as small w. Capital W in fluid mechanics represents the weight. Small w represents the specific weight. So W is equal to density into acceleration due to gravity. So the third property is specific volume. Specific volume is the reciprocal of density. So that is the volume of the fluid occupied for unit mass of the fluid. So volume by mass of the fluid is the specific volume. Next one is the specific gravity. It is defined as the ratio of density of the fluid which is being used when compared with the density of the standard fluid. So standard fluid, what we call it as water. So specific gravity of any fluid can be calculated by dividing the density of the liquid, which is whose specific gravity is to be determined, divided by the density of the standard fluid, water. Usually specific gravity is denoted as represented as S. The another important property of any fluid is viscosity. Density and viscosity goes one on one, because the density of the fluid affects the viscosity. So when the density, okay, let us first concentrate on viscosity. So viscosity is defined as the property of the fluid which offers resistance to the movement of one layer of fluid over another adjacent layer of fluid. So what is the actual meaning is, whenever a fluid is flowing in a container or in any path, the first layer of the fluid will be having a surface tension property, where the atmospheric air will be in contact with the fluid surface. The layer of the fluid from the second onwards, it will be having some frictional resistance between with the other next layer of the fluid. So automatically what will happen when a fluid tries to move from left to right, the adjacent layer of the fluid will always have shows some resistance to the left to right movement of the fluid, and it will make the fluid to tend from right to left, which means the movement of the fluid will be resisted by the adjacent layer. So this property is called as viscosity. Generally, the fluid which is having a high density will have a low viscous property, and the fluid which is having a so density and viscosity are proportionally inversely proportional. So these are all some of the representations. Like a tau is denoted as shear stress, which is proportional to du by dy. So in order to remove the proportionality constant, we are introducing a constant called as a mu. So mu tau is equal to mu into du by dy. So here tau represents the shear stress, du represents the velocity, dy represents the distance between the two layers of the fluid, and the mu is the dynamic viscosity, which we call it as um, simply viscosity. So this is measured only with the by means of shear stress, velocity, and the distance between the two adjacent layers of the fluid where it flows. So the unit of viscosity is Newton second per meter square. In CGS system, the unit is poise, that is dyne second per centimeter square. So Newton's law of viscosity states that the shear stress tau of any fluid element or any fluid is directly proportional to the rate of shear strain. So shear strain is nothing but velocity to distance. So du by dy is called as shear stress. So du by dy is called as shear strain. So the next viscosity is kinematic viscosity. Whenever during the time of problem solving, viscosity is simply if it is given as viscosity means it is known as dynamic viscosity. Kinematic viscosity means it will be represented as kinematic viscosity itself. So kinematic viscosity is defined as the ratio between dynamic viscosity and the density of the fluid, that is mu by rho. It is the definition for kinematic viscosity, and the unit for kinematic viscosity in SI systems is meter square per second, and in CGS systems is centimeter square per second, which we call it as Stokes. So poise is the unit of dynamic viscosity, Stokes is the unit of kinematic viscosity. Based on the unit, we have to assign the data for solving these problems. So next one is the types of fluid. So there are many types of fluids. All those fluids are categorized under these four types. One is ideal fluid, the other one is real fluid, third one is Newtonian fluid, and the fourth one is non-Newtonian fluid. The third one, Newtonian fluid, strictly obeys the Newton's law of viscosity. Non-Newtonian fluid strictly does not obey the does not obey the viscous property. Real fluid is one which is having all the properties always, and ideal fluid is one which is following the static fluid properties. So effect of temperature and viscosity, always viscosity and temperature are inversely proportional to each other, which means the density, a high density fluid. So in the previous slide we discussed like density and viscosity are directly proportional, but viscosity and temperature are indirectly proportional. The reason is when the temperature increases, the thickness of the fluid gets reduced, which means the density will get reduced automatically, the viscosity also gets reduced. So the temperature and viscosity are inversely proportional to each other. So viscous forces can be termed as two types. One is cohesive forces and the molecular momentum transfer. So in the cohesive forces, dominate in the liquid, the cohesive forces dominates due to closely packed molecules, and with the increase in temperature, the closely packed molecules will be dispersing. So it is the reason why the viscosity decreases when the temperature increases. So the next property is surface tension. This we all know. So surface tension is defined as the tensile force acting on the surface of the liquid which is in contact with a gas or on the surface between two immersible liquids. Two immersible liquids means liquid and gas. So some water and mercury. So the two liquids which are not dissolving each other is known as immersible liquids. So here we have the surface tension of a hollow bubble, liquid jet, and others. Then the next property is capillarity. So it is defined as the phenomenon of a rise or fall of a liquid surface in a small tube relative to the adjacent general level of liquid. So whenever a tube both the sides open is kept immersed in any container where the fluid is available, the rise or fall is happening. So this rise or fall of the fluid with relative to the adjacent level of liquid is called as capillarity. When the liquid rises in the tube, it is called as capillary rise. When the liquid falls with respect to the next adjacent level of fluid, it is called as capillary depression or capillary fall. So factors affecting rise or fall is again density of the liquid, diameter of the tube, and surface tension of the liquid. So whatever may be the place of application, the density of the fluid is very, very important during our class hours.